Dear learners, I welcome you all to this online teaching session. Today, we will discuss about practical 7, that is estimation of caffeine and sodium benzoate by absorption ratio method. So, the aim is to estimate percentage weight by weight of caffeine and sodium benzoate in given sample using absorption ratio method by UV spectrophotometry. Requirements: reagents and chemicals required are standard caffeine, standard sodium benzoate, caffeine sodium benzoate injection, and distilled water. Apparatus: volumetric flask of different sizes 10 ml, 50 ml, 100 ml, pipettes, beaker, funnel. Miscellaneous requirements are Wattman filter paper and tissue paper. You require UV visible spectrophotometer for carrying out analysis and high precision weighing balance for weighing purpose. The drug profile is structure of caffeine and sodium benzoate, molecular formula, molecular mass, melting point, Cas number, IUPAC name and uses. Now coming to preparation of solutions. So standard solution of caffeine is prepared by dissolving 5 mg of caffeine in 50 ml of distilled water to get 100 ppm. From this solution 1 ml is taken, 1 ml solution is taken and diluted up to 10 ml, means 10 times dilution is done with water to get 10 ppm caffeine solution. Now sodium benzoate solution is prepared similarly. 5 mg of sodium benzoate is dissolved in 50 ml of distilled water to get 100 ppm of solution, and from that 1 ml solution is taken and diluted up to 10 ml to get 10 ppm sodium benzoate solution. The sample will be in-house prepared injection containing caffeine and sodium benzoate having concentration caffeine 100 ppm as well as sodium benzoate 100 ppm. This injection, in-house injection, is diluted 10 times, means 1 ml of this sample is diluted to 10 ml to get 10 ppm each of caffeine and sodium benzoate. So now we have three solutions with us: caffeine standard solution 10 ppm, sodium benzoate 10 ppm, and sample solution, that is caffeine and sodium benzoate, both the concentrations are 10 ppm. So these standard solutions are scanned in UV from 200 to 400 simultaneously, and isoabsorptive point is measured, and that point will be our lambda 1. What is isoabsorptive point? The point in spectrum where the absorbance of both the component meet each other. So that value will be our lambda 1, and lambda 2 you can take as a lambda max of either of these components. Here we have taken lambda max of sodium benzoate as a lambda 2, and caffeine we have denoted as a X and sodium benzoate we have denoted as Y. Now the absorbance of both the solutions at lambda 1 and lambda 2 are calculated to get AX1, AY1 and AX2 and AY2. AX1, AY1, AX2 and AY2 are absorptivity. So from absorbance, absorptivities for both the component, for both the wavelength is calculated. Now this sample solution containing caffeine and sodium benzoate 10 ppm each, you have to measure the absorbance at lambda 1 and lambda 2 to get capital A1, that is absorbance, and capital A2 respectively. Now from this slide depicts how the absorptivity is calculated. So for absorptivity the equation is capital A is equal to small a b c, where A is absorbance, small a is absorptivity, b is a path length, that is 1, and C is a concentration in gram per 100 ml. For calculation of absorptivity, the concentration should be expressed in gram per 100 ml. So for this 0.775, we will see how the absorptivity is calculated for this reading. So as per this equation, A is equal to ABC, what will be the value of small a? Small a will be A by BC. So AX1 is equal to 0.775 upon 1 is a path length and 0.001 is a concentration of this 10 ppm caffeine solution, which we have converted into gram per 100 ml. So 10 ppm is equal to 0.001 gram per 100 ml. So absorptivity will be 775. Similarly, absorptivity for all these absorbents can be calculated. Now if you substitute the values into this equation, you will get Cx and Cy. But Cx and Cy you will be expressed in gram per 100 ml, because we have, while calculation of absorptivity, we have considered concentration in the unit gram per 100 ml. So again you have to convert the gram per 100 ml concentration into ppm. So how the percentage weight by weight is calculated? The Cx, value of Cx experimentally is 7.526 and Cy is 4.886. So here what was the theoretical value for this sample, caffeine and sodium benzoate? The theoretical value was 10 ppm and 10 ppm. So how for X, that is caffeine, 10 ppm is 100%, so 7.526 is how much percent? So that is 75.26%. Similarly, you can calculate for sodium benzoate also. So theoretical value of sodium benzoate was 10 ppm. So 10 ppm is 100%, so 4.886, which we obtain from this equation. So how much percent is there? So it is 48.66%. So result can be expressed as the given injection sample or sample contains 75.26% of caffeine and 48.66% of sodium benzoate. Thank you for patiently listening. Have a good day.